The first two property that we are learning has got to do with, is more towards the symmetrical properties rather than the angle properties. So for property number 1, we are dealing with perpendicular bisecting chord. So that is the proper name that we want to write in our statement, perpendicular bisecting chord. So locate a chord first. So a chord must touch the circumference. The two ends of the chord must touch the circumference. So where is it bisecting? Bisecting means it cuts into half. So we are cutting a chord into half and at a 90 degree. So that's the meaning of this property. So where will that happen? That will happen from the center. From the center, you move towards the chord. You will get a 90 degree and you will cut nicely into half. So there will be this feature that you will need to take note. From the center, if you move towards the chord, it will cut the chord into half. And it will cut it at a 90 degree. So because of this feature and the feature of a radius, this is where you see right angle triangle. So this is where you see right angle triangle, and this is where you can apply trigo or Pythagoras theorem. So this is the idea of perpendicular bisecting chord. You will use this in A math as well, in A math circles. So the next property is somewhat related to property number 1. So the next property, we are talking about equal chords. That means the chords are same length. So we are going to explore two chords that are same length. So according to the first property, if I have the center, from the center, I will be able to cut the chord into exactly half. So this is the center. I will cut it exactly half. So this is the center. Same thing, I'm cutting it exactly half. So if the two chords are the same from the center, it will be cut exactly half. So what about this distance that we are going to explore right now? So this distance should also be the same. So that's what they meant. Equal chords are equal distance from the center. Okay, so there is a little bit more on this. So can you imagine if I got a shorter chord? Something that is shorter. You can visualize a shorter chord. So this one is you should visualize it as this chord is shorter than X. So from the center, it will still be cut into half. So because this is a chord, so by the use of property 1, I will still be able to cut it into half. But obviously, this distance doesn't look the same. Can you see this distance should be longer than these two? Because the chord is shorter, so it's actually further away from the center. So from here, right, you will see that if you got a very the length of the chord can change. And because the length of the chord change, it will change the distance from the center. It will change a perpendicular distance from the center. But whatever is it, there is something that will not change. The things that doesn't change will be, the one thing that doesn't change will be the length of the radius. It's not possible to change the length of the radius, because the definition of radius is center to circumference. Center to circumference. So the chord length can change. The length from the center can also change, but whatever is it, radius will not change. So there will be this relationship that helps you for certain question.